So here's the outline of the presentation. There are three parts. Part one, I'll start with the aim of the study, which is to explore the potential use of predictive modeling to better inform bail decisions. And if we consider those who are bail refused, is it possible to use criminal justice data and apply a predictive model to identify those who would probably not have offended if they were granted bail? So the idea is that if we could have an accurate predictive model, what's the implication for bail decisions? So that's the aim of the study. In a minute, I'll go through the two specific questions that I'll answer in the end. Then part two, I'll talk about the predictive modeling. I'll talk about the data that we use, the three models that we've considered, and which one we end up using. And lastly, we'll go through the results. So there are three main bail outcomes that we will consider: bail dispensed with, bail granted, and bail refused. And what I have in this sort of timeline diagram is I have the circle represent the offense, and that would be the offense date. The paper icon would be the court attendance notice when someone was charged with a criminal offense. That's the charge date. And finally, the cross at the end, that's the finalization date. So those 3 dates. And what we are trying to predict is if someone is granted bail, whether there would be a new offense, a new proven offense happening between the bail date until the finalization date. So this would be someone. Who granted bail and with a new offense offended on bail, and this would be someone who were granted bail and we see no new offense between that period. So those are the three outcomes. Next, I want to show you the figures in 2016, and what I'm showing you is a horizontal bar chart. And those three bars correspond to the three bail outcomes that we looked at in the previous slide. And we have bail dispensed with, bail granted, and bail refused. And you see that the majority of cases would be in the first group, bail dispensed with, and there are about 30,000 defendants who were granted bail in the blue bar. And finally, we have about 12,000 defendants who were bail refused. In the remaining of this talk, I'll focus on the last two, those who were bail granted and bail refused. Specifically for those who were granted bail, we want to know, we will further split that into two subgroups, whether if they're granted bail, whether they offend or not. So these are the numbers. We have of course, the same number of people who were bail refused in the same year in 2016, and breaking down those granted bail into whether they offended or not, we see there are about 21,000 who did not offend, which is great, and we have 9,000 who did. So those are the three numbers that I would refer in the results. Again, 9,000 offended on bail, 12,000 bail refused in 2016. So the aim of the study is to find out whether predictive modeling could be helpful for bail decisions. And specifically, there are two questions that we want to answer. I'll just tell them what they are, and then I'll explain. So first, whether we could reduce offending on bail. And second, whether we can reduce bail refusals. And when you see, I said, reduce offending on bail without increasing bail refusals, and second question, reduce bail refusals without increasing offending on bail, they seem a bit awkward right now, but in the results section, hopefully it will become clearer. But the idea is that we just want to look at offending on bail and bail refusals one at a time. So that's really that motivates the setup. And perhaps I should bring back the figures from 2016 and where predictive modeling comes in, why it's relevant is that we like to find out, perhaps among those who are bail refused, is it possible that some of these people will not have offended? And if that's the case, and if we could have a model using criminal justice data to identify those individuals, then we could have a reduction in those in the black bar. And what would happen is that since they did not offend under our assumption, then they would go to the blue ones. They would not offend, and so the net effect would be we would see a reduction in the number of bail refused without increasing offending on bail. And arguing along similarly, we could probably achieve some reduction in one without increasing the other. But mainly, can we reduce offending on bail, reduce bail refusals? That's the aim. Now, the part 2, predictive modeling, and the key message here is I'll look at a number of things, but the main message is that we are going to consider 3 models, and one of them, I believe, is more suitable than the most suitable for our data. First, the data set we are using comes from the New South Wales reoffending database. We included every defendants with a charge date between 2011 and 2016. The only exclusions are 2 NSOC, the Standard Offence Classification 152 and 1569. The reason being to derive whether someone offended on bail, we need reliable offence dates. And it turns out in some occasions, for these NSOCs, they are not always reliable, so we excluded them. So that's the data. So next, some terminology. There are 5 of them, and I'll go through one by one. So the outcome, what we're trying to predict is whether there's a new proven offence committed on bail between the date bail is granted and the finalisation date. And when I say predictors, these are variables that we could use from the criminal justice data to predict the outcome. And the important point is that all these variables have to be available on or before the charge date. And that's what I'm going to say about predictors. And next we have the model, and whenever I refer to a model, you can think of it as an approximate relationship between the outcome and the predictors. Their relationship is this. Predictors are the inputs into the model, and from the model we can get our predictions, and to evaluate how good the predictions are, we compare those predictions to the actual outcome, and this is how the 3 terms are related. And the last 2 terms I want to say something briefly is this training test data split. Importantly, the idea is that in this section, in this part of the presentation, we are going to select a model. And the idea is that we should select a model based on the training data and only evaluate the model using test data. And so I have the training data coming from 2011 to 2015, and the test data has come from 2016. The more important, what's important here is that when I show you the hypothetical figures in results, they all come from the test data, and when I select a model in this part of the presentation, they all come from the training data. So some of the predictors, they can be grouped into 3 groups or 3 classes. We have the demographic variables. Examples would be age, gender, socioeconomic index, and we have some variables on the index offence. Examples, whether the offence are indictable, whether it's a summary offence, whether it's domestic violence related, and we have included the NSOC divisions and subdivisions, and lastly, a bunch of criminal history variables. I'm not showing all the variables here, but there are roughly about 45. So these are the inputs into the 3 models, and what we'll do is we will estimate 3 of them, and once we've estimated the 3 models, and we compare the predictive performance, still within using the training data. So as I said, the model captures the relationship. We wanted to capture a relationship between the predictors, the input, and the outcome. And so importantly, I'm going to show you three models. The first one is the simpler of the three. What I have is, imagine we have two predictors, and predictor 1, predictor 2, and the two colors, the colors represent, blue represent bail granted, those who did not offend, and orange represent those who were granted bail but offended on bail. But basically we have two classes, right, of two possibilities of the same outcome. So imagine if you see, obtain a scatter plot, and you see this, and it appears there's a pretty clear pattern or relationship among the predictors and the outcome, and you see that probably there's this line along the diagonal that could probably separate the two classes. So this is known as the boundary, and it looks like it's quite linear. But having said that, the boundary doesn't have to be linear, and it could look something like this, where the decision boundary or the boundary between the two classes, the two colors, are something nonlinear. So in which case we need a nonlinear model. And lastly, something called a non-additive model. We have a relationship that is more complex than all the models to the left. And so these are the three models we will be estimating, and specifically I'll have the logistic for linear, something known as a mass model for nonlinear model, and for the non-additive model, a different mass model here. So taking a step back, we have three models. The model complexity increases from left to right, and we want to find out which model will do best. And to evaluate the model using the training data, I'm going to look at the AUC, the area under curve metric. It's a commonly used metric. What I'm going to say is that it's a one number summary that tells you how well your model is at predicting the outcome. And the higher it is, the better the model is at predicting. And so what we will look at is the AUC for the three models. And in fact, I've done some resampling. I've performed a cross-validation, a 30-fold cross-validation. So each model, I've refitted it 30 times. And what I'm showing you is a box plot of the AUC for each of the three models. And I want you to focus on just the line in the middle. That is the median AUC across the 30 resamples. And you see that the AUC is roughly 0.75. And if we were to relax the linearity assumption, you see that our nonlinear model performs slightly better, but using the more complex model doesn't improve the AUC further. So in short, based on the AUC, we are going to pick a nonlinear model, the one in the middle. So that's the model selection part. Well, you see that the difference between the linear model and the nonlinear model is not that big. It's 0.75. This is just above 0.76. But the model in the middle has an added advantage, which is it would perform implicitly variable selection. It only take in a smaller number of predictors. So that means our model that we end up with is more parsimonious, which is great. So the number of predictors that are selected by the nonlinear model are HS charge date and a couple of variables about the most serious offense charged and some criminal history variables. So in total, it turns out we need 10 inputs, 10 predictors, a nonlinear model, and we can get some predictions. So into the results. First of all, some remarks. So now we have selected a model that we believe would get the most out of the data, and we're going to look at some figures from 2016, and we are going to compare the model predictions on the test data with the actual figures observed in that year. But there's a problem. The model predictions, the outputs that we get from our model are in terms of probabilities. What it tells us is, given an individual, the characteristics that we need, it would give us a number between 0 and 1, and which indicates the likelihood of offending. And so the probabilities and the actual figures that we see in 2016, the three figures we see in 2016, they're not directly comparable just yet. And to enable a comparison between the model predictions and 2016 figures, we need to somehow pick a threshold to coerce these probabilities into decisions of some sort. So I just want to point out we need a threshold here, given that the output predictions are probabilities. So to simplify the argument, I'm going to assume that hypothetically, if we have an individual whose predicted likelihood of offending lies above the threshold to be chosen, then we would refuse bail for this individual. And also, hypothetically, someone with a predicted score below the threshold, we just assume it would be granted bail. So hopefully you see why, with a threshold, we binarize the probabilities into some decisions, hypothetical decisions, but doing so would allow us to compare the model predictions and the actual figures. And lastly, the method I used in the following slides came from this paper by Kleinberg and colleagues in 2017. Just want to point that out. So I'll bring back these figures. I've shown you this. I've shown you these numbers before. So we have the blue bar representing those bail granted, did not offend. The orange bar, those bail granted, offended. And lastly, the 12,000 were bail refused. And what I'm going to do is to take those bars, align them on the same row so that you always see the actual figures in 2016. So now we have the actual figures, we bring in the model predictions. So as I said, the model predictions are in terms of probabilities. So what I have is the likelihood of offending along all horizontal axes here. And what I want to point out is, what I want to say is that, well, think for a moment what we would expect a good model to do. The model outputs a number that, if it's closer to 1, it means the model believes this individual has a high likelihood of offending on bail. And conversely, if it's closer to 0, it thinks that, it doesn't think, but they assign a number that suggests that the individual would have a lower likelihood of offending. So we know that in the first group, the bail granted group who did not offend, we actually get to observe what they have done in 2016. And so we know that they did not offend. And a good model is supposed to give us, to assign these individuals a low score. So we would expect a good model to assign a lot of low scores for this group. For the next group, those who are bail granted and offended, we know that they offended in 2016. We want the model to be able to assign a higher number. So we want the model to put the mass of the likelihood closer to 1. Lastly, for those bail refused, it's not as clear, but because for those refused bail, there's a counterfactual involved. We don't know what they would have done had they been granted bail. So I'll leave that unspecified. So here are the predictions. And what we see is that, as expected, perhaps, for those bail granted did not offend, the model assigned mostly a lower score, say below 0.5. That is great. And what we expected of those bail granted but offended, that did not happen. You see that it assigned quite a lot of people with a low risk of offending. And this is where the model is, in a way, failing. So these would be, the model is not as accurate here. And lastly, I'll just say that for those bail refused, the likelihood of offending ranges from somewhere quite low all the way to close to 1. So again, what we have is, on the first row, actual figures. We have the predictions. What I'm going to do is to apply a threshold and turn these probabilities into what I call hypothetical figures, so that I can compare those with the actual ones. And let's revisit the two questions that I set out to answer, which is, can we reduce offending on bail and without increasing bail refusals? And second question, can we reduce refusals without increasing offending on bail? Hopefully it will become clear why we have this strange phrasing of the questions. So we'll take the first question first. Reduce offending on bail. Again, the actual figures, the predictions, and we are going to assign a threshold here. Let me go back one slide. So the idea is that we make the assumption anyone above the threshold would be remanded, hypothetically. And since we want to compare offending on bail, if we could remand the same people as we did in 2016, then all we need to do then is to compare the number of people hypothetically offended on bail. So let's do that. So this particular threshold is chosen so that the amount of people above it, so these blue bars and these orange ones and those gray ones, they happen to add up to 12,140. Not quite exact, but you'll see that it's below the actual number that were refused in 2016. I would also point out that this is hypothetical because you see we are remanding different people that were actually refused bail in 2016. The actual number of, so the individuals who were refused bail are all here. But according to the model selecting this particular threshold, what we see is that we are actually remanding these people, these ones here, and these ones here. And so any bars that are below the threshold, hypothetically, they're granted bail. What we've achieved so far is that we've matched the number of people bail refused. All we need to do is consider those below the threshold and count how many of them offended. So we can do this one by one. So first of all, those who were granted bail, we observe that they did not offend. The number of people below the threshold turns out to be 19,300. But we know that none of them offended in 2016, so that's great. Next, for those who were granted bail, we have, but offended, we count the number of below the threshold, we see there are 5,648, and we know all of them actually offended in 2016. And lastly, consider those below the threshold, but who were bail refused in 2016. We have 5,312. Imagine if all of these people would have offended if they were granted bail. That means if we add this number to that, I don't know the exact figure, but it's going to be much greater than 9,004. There's a question mark here because we don't know what they would have done, as I said before. So what I'm going to do is to assume some high percentage, say 50. So if we assume 50% of those 5,000 would have offended, which gives us 2006, then we can now add up the number offended under our hypothetical situation, which is 5,006 and 2006. It should add up to some number, it should add up to 8,003. So those are the two figures. Hypothetically, we bail refused a smaller number than we did in 2016. Hypothetically, bail granted offender on bail, we obtained this figure 8,300. And comparing these two numbers, we see that that's a reduction of roughly 700, or equivalently a 7.8% reduction. So we are halfway there. Actually, we are more than halfway there. So the second question can be more easily dealt with by just looking at the threshold. Right now, the threshold is set so that the number refused is exactly 12,000. And since the next question we want to answer is whether we could reduce bail refusals, it may seem reasonable that all we could do is to actually increase this threshold so that we remand fewer people. So what I've done is exactly that. You see that the threshold shifted a little bit, to answer the second question, whether we could reduce bail refusals, we do this exercise in reverse. We look at those who are below the threshold to match the number of people who we expect would offend if granted bail. And we see that those two numbers have matched, and all we do now is to just count the number of people above the threshold. If we do that, it turns out to be 10,000, and similarly, the reduction turns out to be 1,300, and equivalently 11.5. So those are the two questions. So in summary, the two questions we set out to answer: can we reduce offending in bail? Can we reduce bail refusals? The answer is that maybe we can, and assuming that only 50% of those bail refused would have offended if granted bail. Lastly, I'll finish with the limitations of the study. We only look at two numbers. There are other factors that would have influenced the bail decisions, and we ignore them, like likelihood of non-appearance and etc. Offending is measured crudely, as some of the offending that we predicted probably are not serious enough to warrant a change in bail decision. And lastly, there are other important concerns such as fairness and whether the sample is representative. Those are not addressed. And that's the end of the presentation. Thank you.
Thank you, Felix. We're running a bit behind, but I think we've got time for two questions. So 1, 2. So George, you want to go first?
Thank you very much for your presentation. Now, I'm not sure if it's a comment or question, but something to do with your split of training and test. I didn't say your model, so I'm not sure how much of a time series dimension there is in your modeling, but you withhold your last year of observations, and I'm not sure that you need to do that. And by doing that, I'm saying you can grab a random sample as in cross-validation, and that can be your test set and your training. You can split it that way. By withholding your last year of observations, if something has occurred in 2016, you completely miss it in your modelling. If you're taking a time series component, then I understand it. If you're not, you don't need to do that, and you might improve your results by taking a random sample as your test set.
Yeah, I think that's also possible. The only reason I have this split by time is we want to convert those predictions and compare to the actual figures observed in certain time period. And if I were to not use a train test split by time, but just by role, for example, like across the entire period, then what happened is that in my test set, they would be influenced by possibly like changes in the legislations. But apparently I haven't tried that and see whether that would be an improvement. So, but maybe it's something I can consider. Thanks.
Yeah, and last question.
Thanks, Felix. Under the Bail Act 2013, it's only really legitimate for somebody to refuse bail if there's a risk of committing a serious offence rather than any offence. And that word serious is not defined, but it is in other places sometimes as an offence that carries a maximum penalty of 5 years or more. Have you considered, did you make any consideration of the seriousness of the offence that was committed on bail? And do you think maybe the data could be improved and aligned better with decisions that are actually made if you set a threshold for the offence that's committed on bail?
So we have tried two things on the seriousness of the offence. First, we define what serious offences are based on the NSW. We apply a binary model, and unfortunately the AUC or the general model predictions are very bad. And to find out why we split, we estimated a binary model for each of the NSW classes so that we have a separate model for each type of offences. But again, for the majority of these offences, we fail to predict whether there would be, we fail to predict at that level of the offences. So there's still more work to be done addressing the seriousness, but apparently it is a very important concern.
All right, we'll have to wrap that up. Thank you, Felix.